Hello everyone. In this lecture, let us have a look at the third and last operation, that is the bitwise operation. So the first operation we are going to have a look at under bitwise is the AND operation. It is a multiplication operator. It needs minimum 2 inputs. So let's create a variable called bit underscore AND, and let's assign the cv2 dot bitwise underscore and function to this. It takes in 3 arguments. The first argument is going to be img1, which is our first source image. Next is img2, which is our second sourced image. The third and last argument is the mask. This is the operation mask which is generally applied in the end result image. But in most cases, this mask is none. So let us enter the word none over here. Now let us create the code for displaying the two original images, the bitwise AND image, to the user. So now let me execute it and let us see our output. As you guys can see, my first image is on the right, my second image is on my left, and my output image is what you guys see over here. A particular region has been overly highlighted. This is because the multiplication operation has been performed in the bitwise operator. So now let us proceed to the second operation, which is the OR operation. This is nothing but an addition operator. So it performs addition operation bitwise. Like the AND operation, it requires 2 inputs. So let us create a variable bit underscore OR and assign cv2 dot bitwise underscore OR function to this. Now, like the AND operation, it requires 3 arguments. The first is img1, second is img2, and third is our mask, which again in our case is going to be set to none. So now let us create the code for displaying both the original images and the bitwise OR image also. So as you can see, I have entered the code. Let us go ahead and execute it and see our output. So as you can see, the same 2 original images in the left and right, and then our final output, which is the OR operation image, is present in the bottom. So now out of the 4 operations, we have seen the first 2. Let us now have a look at the third operation, which is XOR. In this, it first performs the addition bitwise operation, and then to the answer of the addition bitwise operation is then inverted. So to understand this in better terms, let's say the addition gives us an answer 1. The XOR operation inverts this 1 to 0, and vice versa. So let us create a code for this. Let us create a variable called bit underscore XOR, and let us assign the cv2 dot bitwise underscore XOR function to this. Like you guys guessed, it takes in 3 arguments. Exactly the same 3 arguments your AND and OR operation took in. So it's going to be img1, img2, and our mask, which is going to be none. So now let us create the code for displaying the 3 images. So now that I have created the code, let us run it and see our output. As you guys already know the 2 original images, the output image is seen below. So now Let us have a look at the last operation. This is the NOT operation. What it does is it inverts your input image. So let's say we give 1, it is inverted to 0. If we give 0, it is inverted to 1. A very good example we can associate with the NOT operation is the film which we had when we were using the cameras in the past. We would have a negative image, right? The NOT operation generates the negative of our image. So now let us create a variable called bit underscore not and assign the cv2 dot bitwise underscore not function. This time, instead of 3 arguments, this function takes in only 2. The first being the source image and the second being the mask. As usual, the mask in our case is going to be none. So now let us create the code for displaying the original image and the negative of the image. So now let me run this code and see the negative of my first inputted or read in image. So as you guys can see on your screen, on the right is my original image and on my left is the bitwise not operation image. In other words, it is the negative of my original image. Overall, arithmetic operations helps us in image masking and also helps us enhance the input image's properties. So now that I've completed the different arithmetic operations, I would like you guys to go ahead and change the thresholding values in image blending. Try changing image 1 and image 2, the position in the image subtraction operation, and try different images in the different bitwise operations, which were AND, OR, XOR, and the NOT operation. Thank you. See you guys in the next lecture.